Good day, everyone. Welcome to Grade 7 Science class. I am Miss Eliza, your teacher for today. Our lesson for this quarter is all about motion and energy. We have started with Module 1 by defining what motion is. In today's lesson, we are going to describe motion in terms of distance and displacement. Are you ready? Let's start! Let us recall what we have learned about motion. We have defined motion as a continuous change in position with respect to a reference point for a particular time interval, while a reference point is an object or a place that is used to determine whether something is in motion. Look at the ninja on our screen. Is he in motion? Yes or no? You are right. He is in motion. How do you say so? You are correct. The ninja is in motion because he has changed his position with respect to a reference point. Now, can you name one reference point in the picture? That is right. The bookshelf is a reference point. The frames and the window are also reference points. The ninja started running from the bookshelf to the window. Therefore, the initial position of the ninja is within the location of the bookshelf, and its final position is beneath the window frame. You did well in our review. Now let us power up with some guessing game to kickstart our lesson for today. The title of our game is Near Yet So Far. You will guess the nearest and the farthest country from the Philippines from the pictures that I will show you. Are you ready? Let's go! Look at these countries. Which do you think is the nearest to the Philippines? Good job! It's Singapore that's nearest to the Philippines. How about the farthest? Marvelous! It's India. India is the farthest among these countries from the Philippines. Good job! There you have it. As you can see, Singapore is just 2,355 kilometers away from the Philippines, while India is 4,622 kilometers away from the Philippines. Now we have a question here. When traveling, how do we determine how far are we from our original or initial position? Good guess! We measure the space between our original or initial position and our final destination or final position. Now that space between your initial and your final position is what we call distance. So for today, we are going to discuss about distance and displacement. Our objectives for today's lessons are: number 1, we have to describe motion in terms of distance and displacement. We also have to differentiate distance from displacement. And lastly, we are going to solve problems on distance and displacement. To understand more about our lesson, let us do an activity. Now here are the things needed for our activity. The title is lunch break gala. Now, we need a pen, a ruler, and the map of City High that I have provided you yesterday. For this activity, we have to read the story provided. Then, read the directions to know what to do with our material. After this activity, we have to answer some guide questions. Our guide questions are: number 1, all in all, how far did Abby walk from City High to Edna School? Number 2, how did we come up with this data? And number 3, from City High, is there a shorter way to get to Edna School? Let's start our activity. Here are the materials that we need for this activity. We have to have a pen, a ruler, and our map. Let's start our activity by reading our story. Abby is a grade 7 student from City High. She loves spending her lunch break with her friend from Edna School. During lunch break, Abby walks from City High to Astrodome to buy lunch for her friend. From Astrodome, she crosses the nearest pedestrian lane to get to a gasoline station. From the gasoline station, she walks excitedly to get to Edna School and happily eat with her friend. Our task is to use our pen and ruler and trace Abby's journey on the map as she walks from City High to Edna School. We have to measure the lines connecting each point using our ruler in centimeters. Let's start. From City High, that is point A on the map, Abby walks to Astrodome, which is point B on our map. That is why we have to draw a line from point A to point B. Next, from Astrodome, Abby crosses the pedestrian lane to get to a gasoline station, which is our point C. So from Astrodome, or from point B, we have to mark a line going to point C to our gasoline station. Now from point C, gasoline station, Abby excitedly walks to get to Edna School, which is our point D. So from point C, we have to draw a line going to point D. Now our next task is to measure the line from point to point. Now from point A to point B, I will use the centimeter side of my ruler to measure this line. This line measures 90 centimeters. From point B to point C, it is 25 centimeters. From point C to point D, 90 centimeters. Now, we are ready to answer our guide questions. Guide question number 1. All in all, how far did Abby walk from City High to Edna School? So from point A, from City High, Abby walked to point B, Astrodome, to point C, gasoline station, to get to Edna School at point B. So how far did Abby walk from City High going to Edna's school? Perfect! Our answer is 205 centimeters. Guide question number 2. We came up with this data by simply adding the length of the lines connecting one point to another. This is from point A to point B, that is 90 centimeters. from point B to point C, that is 25 centimeters. And from point C going to Edna School at point B, that is another 90 centimeters. So by adding these values, 90 plus 25 plus 90, we came up with the data 205 centimeters. Guide question number 3. Yes, there is. I would simply walk 25 centimeters from point A to point D. This is from City High to Edna's School. This is the shortest way to get to my destination. By answering the first question in the guide questions given, you have already calculated for what we call distance. Our answer in number 1 is 205 centimeters. This is the actual distance Avi walked from City High to Edna School. And in number 2, how did we come up with this data? How did we calculate for this distance? We simply added the values from point to point. So we added the values from City High, the length from City High going to Astrodome, from Astrodome going to Gasoline Station, and from Gasoline Station going now to Edna School. So that is 90 centimeters plus 25 centimeters plus 90 centimeters for a total of 205 centimeters as our distance. And by answering guide question number 3, we have already calculated displacement. So is there a shorter way to get from City High to Edna School? The answer is yes. We just have to cross 25 centimeters or walk 25 centimeters from point A from City High to point B, Edna School. Great job in answering our activity. Now we are ready to differentiate distance from displacement. Distance is a scalar quantity. It means we only measure the magnitude. Distance is the total path length an object has covered. Example, 30 meters, 40 kilometers, 10 miles. While displacement is a vector quantity, it means we have to measure the magnitude and indicate the direction. We have 4 cardinal directions: north, south, east, and west. Displacement would now be the shortest distance from the initial to final position. For example, 30 meters east, 40 kilometers west, 10 miles north. As you can see, we have the magnitude 30 meters in a direction east. Both distance and displacement can be measured in meters, kilometers, miles, inches, centimeters, etc. But we usually use meters as a standard base unit. Let's have a quick check. Let's identify whether the given is a measure for distance or displacement. Number 1, 700 inches. Number 2, 11 kilometers west. Number 3, 6 centimeters. Number 4, 50 meters east. And number 5, 20 meters. Let's check if your answers are correct. You are magnificent! Number 1 is distance. Number 2 is displacement. Number 3 is distance. Number 4, displacement. And number 5, distance. Now let's dig deeper. How do we calculate for distance? Since distance is the total length traveled by an object or by person, now we have this formula: d total or distance total is equal to distance 1, distance 2, distance 3, 4, 5, and so on and so forth. So we just have to add all the given values for distance. Let's have an example. From the candy store, Abby walks 30 meters east back to her house. As she reached her home, she remembered that she forgot her umbrella in the candy store, and so she walks 30 meters west back to the candy store. Calculate the total distance Abby had traveled. Since we only have two values given, which is 30 meters east and 30 meters west, our formula for distance is d total is equal to d1 or distance 1 plus distance 2. Distance 1 is our 30 meters east and distance 2 is 30 meters west. Therefore, our total distance is 60 meters. We don't have to put any direction because we are only asked to calculate for the distance. To calculate for displacement, we have the formula. Displacement is equal to parenthesis east plus north minus parenthesis west plus south. As you can see, we have the four cardinal directions in our screen. This is the north, south, east, and west. Now we have to combine similar values. Now north and east would be positive values, and west and south would have negative values. That is why in our formula, we have combined the similar values east, positive, north, positive, and west, negative, south, negative. Now we have two values given. We have 30 meters east and 30 meters west. Following our formula, displacement is equal to open and close parenthesis east plus north minus open and close parenthesis west plus south. Let us try to calculate for the displacement. Let us substitute the given values. 30 meters east, that's east, plus north. Since we don't have values for north, I placed there 0 meters. Open and close parenthesis, minus west plus south. Since we have a value for west, now let's substitute it here. 30 meters west plus, we don't have values for south, that's why I put 0 meters. Open and close parenthesis. Do not forget our operation in the middle, which is subtraction. Now let's solve this algebraically. In solving this, we have to solve the ones inside the parenthesis first. Let's have 30 meters east plus 0 meters. That would give us 30 meters east minus 30 meters plus 0 meters would give us 30 meters west. Subtract them since our operation in the middle is subtraction. Let's subtract the values. 30 meters east minus 30 meters west would give us a displacement of 0 meters. You might be wondering why our displacement is 0 meters. Let's go back to the definition of displacement. Displacement is the shortest path from your initial position to your final position. In our example, Abby's initial position is from this one, the candy store. Her final position is the same. She landed here in the candy store again. Therefore, what is the shortest distance between a candy store and a candy store? Nothing, because you just went back to where you came from. So our displacement is 0. Now it's your turn. Calculate the total distance and displacement of Maria, who traveled 40 meters north, 30 meters south, and continued traveling 50 meters north. You may start. Here are the answers. For distance, you should get 120 meters. For displacement, you should get 60 meters north. Do not forget we have a direction for this one, and it is north. Good job! Here is a work from home challenge for you. Try to calculate the distance and displacement by just looking at the picture. That is all for today. Thank you and see you again soon.